Whoever's. Anyway, we today did lesson 3, which is a part 2 of yesterday's lesson. So we're still really focusing on writing equations to model relationships. Just today was from tables, which table of values are going to be so important in this class. I've not yet taught you about linear, exponential, or quadratic functions, but those are all going to be like our main topics this year. Like by the time that 9th graders go to 10th grade, they should know how to recognize and identify linear, exponential, and quadratic functions from a table of values, from a graph, and from an equation. So this is just like really holding your hand and walking you through it. And we're really covering some foundational skills. You need to be able to make an equation from a table of values. And right now, all you have to go off of is looking at patterns. So you have a table of values and it doesn't really matter if it goes this way or if it's like horizontal. The X is usually your input or output. Input, like pretend it's like a machine and you're like plugging in something and getting something out. X is always your input and it's also independent. So you can usually pick what the X's are. I mean, you can usually pick what the X's are. Usually they'll be like just 1, 2, 3, 4, like something in order. But they can be mixed up and it's definitely harder when they're not going by a consistent pattern in the X's. It's harder to see a pattern in the Y's. All right, but you can look for patterns in the columns, you can look for patterns in the rows, but whatever you think the equation is, it needs to work for every single value. So let me think of one. Okay, so I just made a random pattern. It has an equation that I think you guys should be able to identify. What can I be doing to the X to get the Y? Okay. So, okay, what are all the ways that I could go from 1 to 11? Okay, adding 10 is on the table. Does that work for each one?
Yes.
Is 2 plus 10, 21?
No.
So that can't be the pattern, although it worked for the first pair. It needs to work for all the pairs. So what else could I do to 1 to get 11? 5 times, multiply by 11 again? Okay. What's 2 times 11?
22.
Not 21, so that can't be it. What else could it be? Can it be multiple things at once too?
I'm gonna add this.
You can do multiple things to the X. Let me think of any that generated this pattern.
Divided by 1.
Okay, times 11 minus 1. Let's see if it works for all of them, because it has to work for all of them. Hold on, pause. Let's try this one first. So, class, what is 11 times 1?
11.
What's 11 minus 1?
10.
Doesn't work for that one. It does work for 2, but it doesn't work for that one. But we are getting closer. Does anyone have it, they think?
They're good. Still.
What could I do to the X?
That's 10 plus 1.
Okay, let's try that.
Okay.
Times.
No.
Okay, what's 1 times 10? And then what's 10 plus 1? Okay, works for that one. What's 2 times 10? Plus 1 is 3 times 10 is plus 1 is 4 times 10 is plus 1 is 4. So I can say that that's the equation because it works for every pair. Yes? Right now it's kind of guessing and fitting. But on your practice, you'll probably have some options to pick from that you could try out. But in order for it to be the rule for that one, it has to work for each one. Otherwise, yeah, you're kind of just guessing and checking right now. Later on, we'll give you strategies, like later on, we'll tell you that this is a linear function. And that linear functions has the same amount at the y each time. For each increase of x. But we're not there yet, I'm not quite yet. Might have learned it before, but we're not there yet. So, right now it's kind of just guessing and checking, looking for patterns up and down, across. The practice, I think, does a really good job of addressing this, but you need to actually be trying it yourself. Don't just cheat, don't just share the answer with your friends. It's only a 10-point homework assignment, and it's not like it's gonna drastically increase your grade if you get 100% on it. But if you know how to do this skilled, you will do better on the quiz. And then you'll do better on this. And for the rest of this. Questions right now. Okay, so this is what I want you to get 80% or higher on. Feel free to ask me questions. We need to first fill in the values in the table, and then we need to make an equation for something specific that they're asking about. So first, let's fill in what we need from the table. Like in the first row, they're giving us that if they have 2 cups, we need to fill in the number of tablespoons. The reason I'm working this way is because, I mean, tablespoons are the next biggest, and then teaspoons are the smallest. They don't give me a direct conversion from teaspoons to cups, so that's why I'm working like backwards. It goes like smallest, bigger, biggest unit. So in here, the helpful information I need is that 1 cup contains 16 tablespoons. But if I have 16 tablespoons in 1 cup and there's 2 cups, how many total would that be?
16.
32 is correct.
Oh, you're trouble. Change my answer.
You're doubling it. If I have 16 in 1 cup and now I'm asking about 2 cups, I want you to double it. Like so 32 tablespoons are in 2 cups. Now that I have that, I can do the conversion for teaspoons because they did tell me also that 1 tablespoon contains 3 teaspoons. What math do I need to do to find this?
48.
32 times 3. It is 9 cents. Now listen, don't put any extra spaces. Don't even put like your work shown in these little boxes or it'll score it wrong. But that's how we found it in this one. We know there's 32 tablespoons. We know that there's 3 teaspoons for each tablespoon. Multiply it. And that's the first row. Now the next row, we're working from teaspoons all the way to cups. We already have the tablespoons, so let's start there. When I'm going from left to right, I should expect the numbers to get smaller rather than bigger. Okay, so I right now am missing the cups. I know I have 12 tablespoons. Is that going to be smaller or bigger than 1 cup? Smaller, because I know that 1 cup contains 16. Do you know what math I need to do for this one?
Division.
What am I dividing?
1. Well, 30. 63.
Good.
Oh, 16,000.
This is what I'm going to be dividing because really this is something called dimensional analysis, but that wasn't the main point of today's lesson. Whenever you're converting something, so like right now I have 12 tablespoons. And I want to go to cups. The way that the units will cancel out is if they're like diagonal from each other. So essentially what I'd be doing is multiplying by 1. So I know that for every 1 cup, there's 16 tablespoons. That's how I know I need to end up dividing 12 by 16. Because 12 times 1 is 12. There's nothing here, so 1 times 16 is 16. I need to put this in my calculator. So someone do that for me. 12 divided by 16.
Wait.
Okay. I think it should accept if you write it like this or without the zero. I think it'll also accept 3/4, but no other spaces or anything. And if it marks you wrong and you put either one of those two things, then just let me and I'll give you a blank. All right, but also we have one more blank to fill. So this time we're working from cups all the way to teaspoons again. They already gave us the tablespoons. What math do I need to do to go from this to that? Okay, good. And again, if I use like my dimensional analysis setup, so that would be 48 tablespoons. And I want to get to this time teaspoon, so let me reset. For every, let's see, what's the conversion? 3 teaspoons. That fits in 1 tablespoon. So that's how I know to do 48 times 3 because that's the conversion.
Yeah, that was
1 tablespoon, there's 3 teaspoons. And what is 48 times 3? Okay, that's how you fill in the table. Yes. Now this is the hard part. Making the equation to represent what they're specifically asking for. So we want an equation that represents the number of teaspoons contained in a cup. So like, think about when we worked from here all the way back. They don't want you to talk about how you did something with the tablespoons. They want to go directly from cups to teaspoons. So how do we want to do that? What's it? Let's pull up my. Okay, so we want to do something to C to get something like 144. So almost like ignore this middle column. Pretend this is our table of values. What could we do to 2 to get 96? What could we do to 3 to get 144? What did we do to the 2 to get 32? Okay, we did 16 times 2 because that was the number of cups, right? So we'll do 16 times C, but that only gives us a tablespoon. We want the teaspoons. What did we do from 32 to get 96? We times this by 3. So times this by 3, don't type this in just like that. We're going to condense it. Does order matter in multiplication? It does not matter. But 16 times 3?
No.
All right, guys, don't guess. Is it 48?
48. It's yeah.
Okay. So then what needs to go here is 48C.
Wait.
There is 48 teaspoons in 1 cup. If I do 48 times 2, I get 96. If I do 48 times 3, I get 144. If I do 48 times 0.75, I get 36. You could double check if you like. But that's what you want to do. You want to figure out the math that you're doing while you're filling out the table. And then you're going to make an equation that works no matter what you plug in first. Does that make sense? Okay. Let me double check the key, make sure. Okay, yeah, all things we said, yep. 48C, don't put anything extra. Don't put extra parentheses. Don't put an X for the time, so it's gonna mark it wrong. Just put 48C smushed together. I can't split that. Think. Okay, what's the most success? We can everyone pass. Questions on this question? Questions on other, oh, here I scrolled down a little bit. Questions on other question? I mean. No, that was the only question on the homework.
On both sides, or?